Hello everyone, complete unknown Schmichael Phelps here, back to talk to you about scale drawings and models. And I looked on Google and I saw Michael Phelps and we do look very similar. So I understand the confusion. I apologize everyone.
First thing we're going to talk about is a scale model or drawing. That's an object or drawing with lengths proportional to the lengths it represents. Now, the most common type of scale model would be a model airplane, a model train, a toy car. These things are not as big as the things they represent, but they are proportional. They're just shrunk down proportionally. The most common type of scale drawing would be a map. Again, not as big as the thing they represent, but they are proportional. They're just shrunk down proportionally. And that proportionality is based on this scale that you're given in the bottom left-hand corner of your map. In this particular instance, for this scale, we see that the map above has a scale of 1 inch to 175 miles. So we have shrunk down the map of the United States proportionally, so that 1 inch on the map represents 175 miles in reality. Let's talk about distance, rate, and time. So the distance an object travels, the rate at which the object is traveling, and the time the object has been traveling are related by the following equation. Distance is equal to rate times time, or D equals RT. Now this formula comes up all the time, and not only in math, it also comes up a lot in physics. If you want to find the distance an object has traveled, you just take the rate that the object was traveling times the time that the object was traveling at that specific rate.
Time for you to learn from the best. It's example time.
Now, example 1 says the scale on the map shown is 4/10 of an inch to 40 miles. You use a ruler to determine that Huntington Beach is 1.5 inches away from San Diego. So the first thing we're going to do is figure out what is the actual distance between Huntington Beach and San Diego. So the way we're going to do this is we're going to find the actual distance by setting up a proportion. Now, how does this proportion look? Well, the scale that you're given for the map is going to be the ratio on one side. So we're going to have 4/10 over 40. And that's going to be equal to the inches that were given on the map, 1.5, over the actual distance from Huntington Beach to San Diego, which we don't know, so we're going to call X. Now all we have to do is solve this proportion. So how do we solve a proportion? Use the cross product property. We cross multiply, set the two products equal to one another, and then simplify. So here, we're going to take 0.4, multiply that to X, take 40, multiply it to 1.5. We then solve for X by dividing both sides by 0.4, and we get X is equal to 150. But that's not what you're going to write as your answer. You were asked to determine the actual distance between Huntington Beach and San Diego, which we have found is 150 miles. Now part B says, assuming you're traveling 65 miles per hour in a straight line, how long would it take you to get there? So the way we're going to do this is we are given the rate at which you are traveling in a straight line from Huntington Beach to San Diego. We have also found the distance that Huntington Beach is away from San Diego. So to determine the time that it's going to take to get there, we just use that distance formula. Distance is equal to rate times time, or D equals RT. Our distance, we said that Huntington Beach was away from San Diego, we found to be 150 miles. The rate we now know is 65 miles per hour. And the only thing we're missing is this time that it's going to take to travel 150 miles. So how do we find that? We just divide both sides by 65 miles per hour. We solve for T, and we get that T is approximately equal to 2.30769 hours. So we know that this is going to take about 2 hours. But let's say I want to figure out the minutes as well, because normally you want to know hours and minutes. So what is 0.30769 of an hour? How do we figure that out? We just take 0.30769, multiply that by 60, and that'll give us the number of minutes. So if we multiply these together, we get about 18.46, or 18 minutes. So to travel 150 miles, traveling at a rate of 65 miles per hour, it's going to take you about 2 hours and 18 minutes.
Time to go for the bronze. You try.
Okay, this says the scale on the map shown is 5/10 of an inch to 50 miles. You use a ruler to determine that Manhattan is 3/16 of an inch away from Staten Island. So we first want to figure out what is the actual distance between Manhattan and Staten Island. So again, the way we do this is we set up a proportion. On one side of the proportion, our ratio is going to be the scale that we are given, 5/10 of an inch to 50 miles. On the other side, we're going to have the inches over miles. So the inches, we know the distance we measure on the map that Manhattan is away from Staten Island is 3/16 of an inch. So that's going to go in our numerator in the right ratio, and our denominator is the actual distance from Manhattan to Staten Island, which we don't know. That's what we're trying to find. So we're going to call that x. Now all we have to do to figure out that actual distance is solve this proportion. We just use the cross product property, cross multiply, set the two products equal to each other, and solve for x. So the way I solve this for x is I just divide both sides by 0.5 and I get x is equal to 18.75. But that's not what you're going to write as your answer. You are asked a question. What is the actual distance between Manhattan and Staten Island? So you're going to say the distance between Manhattan and Staten Island is 18.75 miles. Part B says, assuming you're traveling 35 miles per hour in a straight line, how long does it take you to get there? So we are again given the rate that you are traveling. We already know the distance from Manhattan to Staten Island, and we are trying to figure out the time that it will take you to get there. So we need to use that distance formula. Distance is equal to rate times time, or D equals RT. Our distance we found to be 18.75 miles. The rate that you are traveling is 35 miles per hour. So the only thing you need to find is this time, T. How do we find that? Well, we just solved this equation for T. We divide both sides by 35 and we get T is approximately equal to 0.5345 of an hour. Now you can't leave your answer like this because nobody knows what this means. You're never going to ask somebody, how long is it going to take me to get there? They're going to say 0.5345 of an hour. No, they're going to tell you how many minutes it's going to take. So we take that 0.53457 of an hour to figure out how many minutes that is. We just multiply it by 60 and we get that it's going to be about 32 minutes. So this trip from Manhattan to Staten Island, if you're traveling 35 miles per hour, it's going to take you about 32 minutes. Now, example 2 says Parker makes model airplanes. One of his planes is 6.5 inches long when the actual plane is 13 feet long. What is the scale of the model? How many times as long as the actual plane is the model? So the first thing we are tasked with finding is the scale of the model, and that's actually pretty easy. It's just going to be the simplified ratio of the length of our model over the length of the actual plane. So it's going to be 6.5 inches over 13 feet simplified. So how do we simplify this? Well, there's two ways. You could either recognize that there's a decimal in this ratio and get rid of the decimal by multiplying the numerator and denominator by 10 and then simplifying, or you can see right away that 6.5, that's half of 13. So if I divide the numerator and denominator by 6.5, I can get that my simplified scale here is going to be 1 inch to 2 feet. Next, we have to figure out how many times as long as the actual plane is the model. So the way we're going to do this is we're going to take our scale, and we need to make sure that we have our image measurement over our pre-image measurement. And in this question, we are going from the actual plane to the model. So the actual plane measurement is our pre-image, the model is our image. So we do have it like that, perfect. Once you confirm that, all you have to do is take this scale and make sure that the numerator and denominator of your scale have the same units. So I could either convert my numerator to feet, or I could convert my denominator to inches. Well, I'm obviously not going to convert my numerator to feet because this would be 1/12 of a foot. So down here, I could just convert this to inches by multiplying 2 by 12 because there are 12 inches in a foot. So if I multiply that 2 by 12, I get 24 inches. There are 24 inches in 2 feet. Now, all you have to do to determine how many times as long as the actual plane is the model is just drop our units here. And we can say that the model is going to be 1/24 times as long as the actual plane. So if you were to take any measurement on the model, it's 1/24 times the corresponding measurement on the actual plane.
Schmeichel Phelps says it's okay to be mediocre. You try.
Okay, this time it says David collects Hot Wheel toy cars. The toy sports car is 33 centimeters long when the actual car is 11 feet long. What is the scale of the toy? How many times as long as the actual car is the toy? So the first thing we have to do is find the scale of the toy car. And remember, that's easy. You just create the simplified ratio of the measurement of your toy car over the measurement of your actual car. So that would be 33 centimeters over 11 feet. Now, if we were to simplify this, all we have to do is divide the numerator and denominator by 11, and we end up getting a scale of 3 centimeters to 1 foot. So 3 centimeters on your toy car represents 1 foot in the actual car. Next, we need to figure out how many times as long as the actual car is the toy car. So the way we're going to do this is we're going to take our scale model, make sure the image is over the pre-image. The image is in the numerator and the pre-image is in the denominator. Well, we're going from the actual car to the toy car. So the actual car is our pre-image, that should be in the denominator, which it is. The toy car is our image then, which is in the numerator, perfect. So we're going to take that ratio, that scale that we found, found. We're going to make sure that the numerator and denominator have the same units. So we can either convert centimeters to feet or feet to centimeters. Well, you don't want to convert centimeters to feet because then there's going to be a fraction up here. So we're going to convert feet to centimeters. So how do we do that? Well, how many centimeters are in a foot? Well, it's not pretty. There's 30.48 centimeters in 1 foot. So we're going to rewrite this 1 foot as 30.48 centimeters. Now we can simplify this. So to figure out how many times as long as the actual car is the toy, we're going to drop our units here and we are going to simplify this ratio. Now we have a decimal in our fraction, so we need to multiply the numerator and denominator here by 100. That'll get rid of the decimal in the denominator. Now we can simplify. If we were to simplify this ratio all the way down, we end up getting 25 over 254. So you could say that the model is 25 over 254 or approximately 0.098 times as long as the actual car. Now, example 3 says choose an appropriate scale and construct a scale drawing of a high school basketball court with length 84 feet and width 50 feet. So it would fit on an 8.5 by 11 inch sheet of paper. So the first thing you need to note here is that answers may vary. You may get a different scale than I do, and that's okay as long as your basketball court still fits on this sheet of paper. So the first thing I'm going to do is I'm going to choose a new size for one of my dimensions here. Which dimension do I want? It doesn't matter. I'm going to say the length. I want to choose the length to be a specific amount of inches that will fit on this sheet of paper. So I'm going to say the length of this basketball court is going to be 7 inches. Why? Because 7 goes into 84 nicely. And now that we have a measurement on our sheet of paper and a measurement in real life, we can create the scale of this drawing. So the scale is going to be the measurement of the length of the basketball court on your sheet of paper over the measurement of the length of the basketball court in real life. We can then simplify this down. Again, we chose 84 because it's divisible by 7. When you simplify that down, you get a scale of 1 inch to 12 feet. So 1 inch on your sheet of paper is going to represent 12 feet of your actual basketball court. Next, what you have to do is check to make sure that this scale that you found is going to work for your other dimension as well. To do that, all you have to do is set up a proportion and solve for the width of your basketball court on your given sheet of paper. We'll call that X. So we're going to say that our scale, 1 inch to 12 feet, is going to equal X over 50 feet. That will tell us how many inches wide the basketball court is on your sheet of paper. So all we have to do to solve this proportion is cross multiply and then set those two products equal to one another, and then we can solve for X. So we divide both sides by 12. We get X is approximately equal to 4 17/100ths of an inch. We now have to check, do the dimensions that we've chosen for our scale drawing of our basketball court, do those dimensions fit within our dimensions of our sheet of paper? Well, yeah, this is 4 17/100ths of an inch. This is 7 inches. That's going to fit well within the 8.5 and 11 inches. Therefore, we can say that our scale of 1 inch to 12 feet is an appropriate scale. Again, answers could vary. You could have a different scale than this as long as your length and width fit within the dimensions of this sheet of paper.
Please don't fail on this. You try like I did in my swimming career.
Okay, this time it says choose an appropriate scale and construct a scale drawing of a professional football field with a length of 120 yards and a width of 53 1/3 yards, so it would fit on a 8.5 by 11 inch sheet of paper. So we're again dealing with the same size sheet of paper, but this time we have a football field. Please note again that answers may vary. Your scale could be different than my scale. It's okay as long as your scale drawing still fits within the dimensions of this paper. So the first thing that I'm going to do is I'm going to select a new size for one of my dimensions here. Doesn't matter which one, but I'm going to pick this 120 yards because that's a little nicer to work with. So I'm going to choose a length that's going to fit on this sheet of paper and is nicely divisible into this 120 yards. So how about 10 inches? If I make the length of this football field 10 inches, that's going to fit within that 11 inch range right here. So now that I've selected the new size for one of my dimensions, I can create a scale. And that scale is just going to be the length of the football field on your scale drawing over the length of your football field in real life. And what we have to do is simplify that down. So how do we simplify this? Well, each of these are divisible by 10. That's why we chose 10. So if we were to simplify this down, we can say that our scale is going to be 1 inch to 12 yards. So 1 inch on our scale drawing is going to represent 12 yards in our actual football field. Next, we have to check to make sure that scale works for our other dimension over here. So what is the width of the football field in our scale drawing? We'll call it X for right now. To determine what that's going to be, we just take the scale that we found, 1 inch to 12 yards, we set up a proportion, and we solve for X. So we say 1 inch over 12 yards yards is going to equal x over the actual width of the football field, 53 1/3 yards. So again, to solve for x, the width of the football field on our scale drawing, we just use the cross product property to solve this proportion. We multiply across, set the two products equal to each other, and solve. We divide each of these by 12, and we get that x is approximately equal to 4 4400ths of an inch. Now, does that fit? Yes, if the width of this football field on our scale drawing is this measurement, that's well within the 8.5 inches on our sheet of paper. Therefore, the scale of 1 inch to 12 yards is an appropriate scale for this football field.